Hello everyone, in this video we'll discuss about problems based on network theorems. The first problem is belongs to the superposition theorem. So we'll see the what is the problem, what we have to find out. Find I naught in the network shown in figure using superposition. So you have to find out the problem using superposition theorem. In this, what you have to find out? I naught. Where is I naught? So where I naught is the current flowing in 12 kilo ohm resistor. So this 12 kilo ohm resistor current we have to find out. First we have to follow the steps related to superposition theorem. The first step in the superposition theorem is observe the circuit. So which value we have to find out, so that we have to check in this problem. So circuit we have to observe. Circuit we have to observe. And second point, so we have to deactivate the sources and activate the individual sources. Suppose here voltage source is there and current source is there. So we have to deactivate any one source, and we have to activate one source at a time. And we have to find out the value in that condition. So here I naught 1. So when voltage source is acting in the circuit. And the fourth one is, so I naught 2 we have to find out when current source is acting. So here voltage sources always we should consider as a short circuit, and current source always we have to consider as a open circuit. These rules we have to follow. And finally what we have to do, the total current I naught is equal to algebraic sum of I naught 1 plus I naught 2. So this is the steps we have to follow while we are doing the problem. Okay, so we'll move to the steps. See here, current source we have to make it as a 0. Current source should be 0. Then apply current source should be 0 means current source we have to open circuit. Current source should be open. Then apply current superposition principle and find the I naught 1 or I naught dash. So we will see the how they applied. So your circuit it will be like this, and simplify the resistors, series resistance and parallel resistance, and apply KVL and find the I naught 1 or I naught dash. So I naught dash is equal to minus 6 by 8 plus 12. 8 plus 12 is here these 2 kilo ohm resistors are series, and then it will be parallel to this 12 kilo ohm resistor. So combination you have to find out this. So this will be equal to 8 kilo ohm. 8 kilo ohm and 12 kilo ohm is in series. So then 20 kilo ohm will come. So minus 6 divided by 20 kilo ohm. So finally what we will get? Minus 0.3 milliamperes. So while we are going to second step is, so deactivate the voltage source as a short circuit. Here we have deactivated voltage source as a short circuited. We are activated current source that is 4 milliamperes. Then I A is equal to I into R2 divided by R1 plus R2. So R1 is 12 kilo ohm plus 12 kilo ohm parallel. These two is parallel, and series with this 12 kilo ohm. So finally is equal to 8 kilo ohm will come. So 8 kilo ohm and 12 kilo ohm, 18 kilo ohm and 12 kilo ohm is there in circuit. Then find out the IA using current division principle. So current division principle, IA is equal to opposite resistor into total current divided by total resistance. Okay, so then IA value is 1.6 amperes. Total current in the circuit is 1.6 amperes. Okay, so then I naught double dash is equal to I naught dash plus IA into 12 divided by 12 plus 12. So 0.8 amperes will give. So according to superposition principle, the current is equal to algebraic sum of currents at each individual source acting alone. So minus 0.3 plus 0.8 amperes is equal to 0.5 milliamperes. So this is the current in this. So where 12 kilo ohm resistor. So according to superposition principle, so the current in this 12 kilo ohm resistor is equal to once voltage source acting current plus once current source acting current. So total is equal to 0.5 milliamperes. So this is how we have to do this type of problems. Okay, so one more problem based on Thevenin's theorem. Find the Thevenin's equivalent for the circuit shown in figure 3.14 with respect to terminals AB. So AB, where is AB? So we have to do this problem based on Thevenin's theorem. So first we have to observe the circuit. What we have to find out? Um, we have to think, and so Thevenin's equivalent circuit we have to find out between terminals A and B. There is a question here. So where is AB? We have to observe, and we have to find out the open circuit voltage. Open circuit voltage means across AB terminals. Across AB terminal parallel 6 ohm resistor current, 6 ohm resistor voltage we have to find out. So we have to observe the circuit. We have to observe the circuit, and second one is so open circuit voltage we have to find out. Next one, Thevenin's resistance we have to find out, and fourth one is find the equivalent circuit of Thevenin's. Equivalent circuit you have to find out. Thevenin's equivalent circuit you have to find out. So that these four steps we have to follow this problem. Okay. So we'll see how we will find out this problem. So find VAB is equal to VOC. So open circuit voltage we have to find out across 6 ohm resistor. So apply KVL to this loop. So minus 20 equal to current we have assumed is I current. So here current is I. So 20 minus 20 plus 6 minus 2I. So this is the voltage current dependent voltage source. So minus 2I plus 6I equal to 0. So if you simplify this one, I value you will get 2 amperes. So 2 amperes, 2 into 6. So open circuit voltage is 12 volt. So current will not flow to 10 ohm resistance, that's what we will not consider. So VOC is equal to 12 ohm. Next one, RT we have to find out. So RT, how we will find out? So we have to deactivate all the sources. So current source is there, we have to deactivate as a open circuit. Voltage source is there, we have to deactivate as circuit. So this will be deactivated, this will be deactivated as a short circuit, and 6 ohm and 6 ohm will be parallel. So here RT is equal to 6 ohm is parallel to 6 ohm and series to 10 ohm. Series to 10 ohm we have to find out. Otherwise we can find out open circuit voltage divided by short circuit current. So okay. So first you find out the RT. Find out the RT. RT is equal to 2 divided by 120. So that is equal to 13.6 ohm. Okay. So these are the problems based on superposition and Thevenin's theorem. Okay. Thank you everyone.